coagulation, that how healthy endothelial keeps the blood remains in liquid state. You should know one more thing about the healthy endothelial tissue, that suppose this is our healthy endothelial tissue, and if and this healthy endothelial tissue would not allow any coagulation factor in this healthy area. Suppose this in this area coagulation is going on. Okay, and what is coagulation? Coagulation is the conversion of fibrinogen into fibrin strand. As soon as any fibrin strand enters in this area, fibrin strand enters in this area, what happened? Immediately healthy endothelium activates the tissue plasminogen activator. Okay, and what is the function of this tissue plasminogen activator? It activates the plasminogen into plasmin. Okay, and what this plasmin do? It plasmin disintegrate this fibrin strand into its disintegrated part, and from where the plasminogen comes in blood, it comes from liver. Okay, so this is one more function of healthy endothelial tissue. As soon as any fibrin strand enters into the healthier part, immediately a healthy endothelial tissue releases a plasminogen activator, and this plasminogen activator activates the plasminogen into plasmin, and this plasmin disintegrates the fibrin strands. Okay, now we'll talk about the damaged tissue. Before that, we should know how endothelial tissue may injure. There are so many factors through which endothelial tissue can be injured. The factors are it may be thermal injury, it may be antigen-antibody complexity. Endothelial tissue can damaged by any trauma. It can damaged by canalization inside our vascular system. So you should know how endothelial tissue can be damaged. Now what happens? If any part, suppose this is our endothelial tissue, and from here we have seen the tissues are damaged. As soon as tissues are damaged, there must be blood leakage from the damaged tissue. But our vascular system knows how to keep the blood remain in vascular system, or how to stop the loss of blood from our damaged part, because blood is very important fluid inside our blood. Now what happened, as any injury happen inside the blood vessels, our tissue acts as a vasoconstriction. Okay, how? Our tissue acts as a vasoconstriction, and the vasoconstriction process done by three ways. First one, as any part is ruptured here or damaged here, the neurons around is also damaged, and the neuron produces vasoconstrictor. Okay, now this type of constriction is called neurogenic reflex constriction. Okay, now we have some soft tissue around the damaged part, and this soft tissue also damaged, and the constriction inside the soft tissue is called myogenic reflex constrictor. And the third one, this is first, this is second, and the third one, endothelial tissue itself acts as a vasoconstrictor. You should know one thing, healthy endothelial acts as a vasodilator. It produces some chemicals like prostacyclin, nitric oxide, we have discussed in our previous video. This prostacyclin and nitric oxide not only acts as an antiplatelet aggregating agent, it also acts as a vasodilator. But unhealthy or damaged endothelium produces a special type of chemical that is called endothelin. This is called endothelin. Okay, and this chemical acts as a vasoconstrictor. There are the three ways how blood acts as a vasoconstrictor, how blood got constricted when there is a damage inside the blood vessels, and it reduces the blood loss from the damaged part of the tissue. Okay, now let's talk about the mechanism done by damaged part. Okay, mechanism done by damaged part. See, this is our damaged part, and our damaged part releases a special type of chemicals. This damaged part do not have any antiplatelet aggregating agent, coagulant agent, antithrombotic agent. That means there is a lack of heparin sulfatase, thrombin modulin. That means it is chance to aggregate platelets here. But how? Some chemicals are releasing from this damaged part. Some chemicals releasing from this damaged part, and the name of this chemical, you should know the name von. See, I am making VW. Von Willebrand factor. Okay, these von Willebrand factors are releasing from damaged tissue. And what is the function of this von Willebrand factor? It acts as a glue over the damaged surface. It acts as and it pasted over the exposed collagen. It got stuck with the exposed collagen, and the another part is hooked with platelets. Okay, platelets. That means this chemical initiate the platelet or activate the platelet to adhere with itself. Okay, and this adherence of platelet with non-platelet agent is called platelet adhesion. Called platelet adhesion. You should know this term. What is platelet adhesion? The combination or the clumping of platelet with non-platelet is called platelet adhesion. The adherence of platelet with this chemical von Willebrand factor is called platelet adhesion. Okay. In this way, von Willebrand factor hooked with platelets, it acts as a glue over the exposed surface or over the damaged surface. Now what happened? What is the purpose of the attachment or combination or clumping of these platelets with this von Willebrand factor? See, we have discussed in our previous video that we have so many receptors around platelets. Okay, and this von Willebrand factor stimulate this platelet to perform its function. Okay, it stimulate these receptors to perform its function. The function is what? The function is to aggregate in the damaged part, over the damaged part. Okay. So the function of this von Willebrand factor is to initiate or activate the receptors which are in sleepy condition in healthy around the healthy endothelial tissue. These receptors are in inactivated state, but as the tissues are damaged, von Willebrand factors are releasing from the damaged part, and it activated the receptors. Now what happened after activation? After activation, platelets have a special type of enzyme that is called phospholipase. And this phospholipase, undergoing different reaction, produces a special type of chemical that is thromboxane A2. Okay, thromboxane A2. What is the function of this thromboxane A2? Thromboxane A2 acts as a vasoconstrictor, and it also acts as a platelet aggregating agent. Okay. Now you have seen how interesting the mechanism is. Damaged part, healthy part releasing a special type of chemical which helps to keep the platelets away from the healthier part, and unhealthy part releasing another type of chemical which acts as a glue over the damaged part, and it activated the receptor to perform its function to release some special type of chemicals which helps in platelet aggregation over the damaged part. Now this thromboxane A2, you can compare it with the substance releases from healthier endothelial, that is prostacyclin. What is the function of prostacyclin? Prostacyclin acts as a vasodilator, but thromboxane A2 acts as a vasoconstriction. Prostacyclin acts as a antiplatelet aggregating agent, but thromboxane A2 acts as a platelet aggregating agent. Prostacyclin acts as a releases from the endothelial tissue, healthy endothelial tissue, but thromboxane A2 releases from unhealthy endothelial tissue. So this is the chemical release from platelets after the activation of receptor. Some more chemicals also release from platelets after activation, but before that you should know the name of this receptors present around the platelets. The name of this receptor is glycoprotein. Glycoprotein. The name of this receptor is glycoprotein. What is the why glycoprotein 1b? This glycoprotein 1b helps in aggregation of platelets. Some people do not have glycoprotein inside their platelets, and they have lack of platelet deficiency disease, but they have platelets inside their blood without receptors. So their platelets won't be able to plug around the damaged part. Okay. Now we'll discuss about some more chemicals releasing from the platelets. Okay. See, after activation receptors are activated, and there are granules present deep inside the platelet. Okay, and after activation, this granules comes near the surface, and it starts producing chemicals. Okay, you should know at least two granules name. The one is delta and the another is alpha. See, this is delta. This is delta is also called, this is called delta granules. It is present inside the platelets, and this is alpha granules. Okay, delta granules, it looks like a sac. See, SAC. Okay, and delta granule have S serotonin protein, A ADP, and C calcium. It has serotonin, it has ADP, and it has calcium. Now, what are the purpose present these chemicals inside the delta? Serotonin acts as a vasoconstrictor. Okay. ADP, it initiate the inactivated receptors around platelets. Though this area releasing what? Releasing their chemicals continuously, and this area becomes high concentrated of ADP. Okay, ADP concentration of ADP is high here. If by chance any platelet come here, and it got combined with ADP, this ADP activated this receptors, okay, and attract this platelet to aggregate here. Okay, to aggregate here. In this way, platelets are getting aggregated over and over. Now platelets comes and stick over the platelets, aggregate over each other, and this type of aggregation is called primary aggregation. Primary aggregation. Okay. Now what is the role of calcium? Okay. We know that alpha granules have coagulating factors, and this coagulating factor converting the fibrinogen into fibrin strands, and these strands comes over this platelets, okay, and makes this plug more stronger. Fibrinogen converting into fibrin strand, and these fibrins are settled over this platelets, and this type of aggregation is called secondary aggregation. Secondary aggregation. Okay, and in this way a semi-solid plug is formed, and it stopped, and it got plugged with the damaged part and stopped the blood loss from the damaged tissue.